Hello everybody, my name is Karl Wakelin from Stephenson Turner. I'm actually going to talk about a project that I worked on in San Francisco in California. I've just recently come back from 6 years away. I spent 3 years in France and then 3 years in San Francisco. There I worked for a large structural engineering firm that actually had a building sustainability wing called Thornton Tomasetti. And we worked on numerous sustainability projects, implementing lots of different sustainability strategies. When I left, I had about 45 lead projects that I had to hand over. And I'm just going to talk about water recycling today, which is one of those sustainability strategies that we were a part of. So the question I want to answer today is why was water recycling in new buildings starting to become a thing in San Francisco? And basically there's a lot of reasons, and some of those are listed up there, and I want to go through the drought situation, the potable water savings, also the municipal leadership of San Francisco, as well as in particular a case study, Oceanwide, as well as a couple of completed projects that we worked on, and then also touch on the New Zealand context. So, climate context in California, as you are probably all aware, it's not good. There has been a drought there for at least the last 5 years, and some would say for the last 20 years. California relies on the Sierra snowpack to store water during the winter months, and then to melt and replenish the reservoirs during the summer months. The image on your left is January 2013. You can see the snowpack is reasonably good. It's not as good as it was probably in the early 2000s, but the image on your right is 1 year later, January 2014, and you can see the snowpack is severely depleted. So there is major water shortages. When I left in December last year, they were saying, the city officials and the sort of Californian officials were basically saying that there's approximately 2 years worth of water left in California, which is pretty scary and was one of the reasons why I decided to come home. So, also want to touch on the municipal leadership of San Francisco, and this is one of the big reasons why a project of this size is thinking about implementing water recycling systems. So the first reason is the purple pipe zones here. You can see it marked out on this map. San Francisco City has committed to supplying municipally supplied recycled water in those purple areas in the future. It's not happening yet, but as a result, every new building that is built in this, downtown here and around the Presidio, has to be capable of taking that water from the street and up into the building and using it for flushing toilets or irrigating in the future. So as a result, these new buildings are going up, and that is a base cost that doesn't have to go against the new greywater system, because they've got to do it anyway. Another reason is the San Francisco Green Building Ordinance. This is basically mandating that most new buildings have to achieve a LEED Silver rating or a LEED Gold rating, or sometimes a Green Point rated rating, which is the Californian rating system. And so as a result, the general level of sustainability in San Francisco and their buildings is pretty high. And so if you want a point of difference, then you're going to have to sort of aim for either LEED Platinum or high LEED Gold. And to get there in San Francisco, you do need to do some sort of water recycling. Another reason is health code. In 2011, the Department of Health basically made it possible to do a greywater or blackwater system, so obviously that is important. And there's also been recent policies starting, I think it was just last year, at the end of 2015, they mandated that any new building of 250,000 square feet or more, so about 80,000 square meters, so a big building, has to investigate water recycling and either do it or prove to the city why it's really just not feasible. And in most cases, they will end up doing some kind of recycling. There's also incentives. There's a $250,000 grant that's been available for any building that can save 1 million gallons per year for 10 years. And they get that grant up front, and that is from the city of San Francisco. Also priority processing. If you can show you're going to get a high LEED rating, you'll get fast consent and processing, as well as entitlement benefits. You can it helps that process, and it also helps you sell your building to the community as well, because the community in San Francisco has a lot of say in what is built. And then another reason is the tech boom. A lot of these, the new tenants in San Francisco, they want to be in buildings that have new innovative technologies and a water recycling system where they can say they're saving 50% in potable water is something that they are definitely interested in. So those are sort of the main reasons why a project of this size is starting to look at water recycling. So this is the Oceanwide Centre project. It's downtown San Francisco. The sort of total cost is around about $1.6 billion, 2 million square feet or 185,000 square meters. Consists of 2 towers on your left there, Mission Tower. Whoopsie, do it again. Mission Tower here, this is going to be a high-end hotel on the bottom half of the building, and then high-end residential in the top half. And then the first tower, this one here, is going to be 2/3 office and 1/3 high-end residential as well. And it's also targeting LEED Platinum because they want to have the point of difference. LEED Gold is required. And also because they're in a particular area of San Francisco, they actually have to get LEED Gold, but they can't count 14 of those points. So they actually have to go from 60 points to 74 points, which basically means they're already at LEED Platinum, which is 80 points. So they only have to push for that extra 6 points. Okay, so I just wanted to quickly show this as kind of the scale of the project. This is first tower here, around about 900 feet, 300 meters tall. Mission Tower is just behind it. This building here is the Trans Bay Tower. It's actually now called the Salesforce Tower. They'll be the 2 tallest buildings in the city. And just wanted to touch on, this is 181 Fremont, and this is actually topped out and not far from being finished, and that has a greywater recycling system in it as well. So this is not the only one that I'm talking about tonight. And this is my building over here where I worked, which used to be the tallest building in California. Not anymore. Okay, so wanted to quickly touch on who's involved in designing one of these systems and implementing it. Basically the whole design team, as you can imagine, it's very integrated. We held water reuse calls like every 2 weeks in the early stages of design with the design team spread across the world. So the owner obviously has to buy into the project, buy into the system. The architect needs to find the space for the system and also design the floor plan so that it makes sense. Civil engineers have to provide stormwater calculations, rainwater calculations. Mechanical engineers, plumbing engineers, for obvious reasons, they have to be involved. And then the landscape architects have to give landscape area ideas sort of at the start, so you can calculate how much water is going to be used in irrigation. Green building consultants, myself, we were there basically to manage all of these people and make sure that the process was running smoothly, and that also LEED and city requirements were being met in terms of sustainability. And then we also found it beneficial for a water reuse vendor to be involved as well, because technically they knew a lot about their own systems. They knew the size and what was involved. So they were actually brought in quite early on in this project. And then city officials, for obvious reasons, we wanted to keep them happy, definitely on a project of this size. So to begin with, when you're designing one of these systems, you need to sort of develop a number of inputs. You need to look at your conservation objectives. For this project, it was at least 50% potable water savings for the building, and also with the aim of supplying 100% non-potable water for landscape irrigation. Mixed use occupancy, you also need to look at the occupancy and how they're going to relate. This building, especially first tower, the larger one, had a nice synergy between the residential condos in the top third and the office building in the bottom, because in the residential units, you have lots of people taking showers, and that water is then used to flush toilets in the office building. So it actually makes a lot of sense, and these types of systems make more sense in most cases in mixed use buildings. You need to look at alternative sources: stormwater, rainwater, drainage foundation. Also, what are your end uses? Toilet flushing and irrigation for the most part, and sometimes cooling tower makeup. That makes sense. And then also space. Where could it go? And then also obviously costs and LEED goals as well. How many points are we looking at with this type of system? Once you have the inputs, you can then develop your outputs. The first thing is your water balance, and you can can actually start to see where your water is going to be used and where it's coming from. Also, you can start to develop a sort of preliminary design and then make some conservation projections, and then also allocate space within the building and actually decide on how much space is required for one of these systems. And as you'll see, they're not that small. You actually do need a fair bit of space. You can also then start to look at paybacks and then lead implications. How many points will we actually achieve with the conservation projections that we're looking at? So this is the system. Just quickly, we'll run through how it works. We have the water from the hand basins, clothes washers, showers. It comes down and is basically stored in the bottom of the building in a collection tank, and then it comes up and through this Aquacell unit, which is actually an Australian-based system. First of all, it goes through aerobic screening, and then biological treatment, and then ultrafiltration, ultraviolet disinfection, basically UV, and then chlorine residual protection. That's just an additional step. So there's 5 steps of treatment, and then it goes to the treated water storage tank, and then up and can be used for irrigation and toilet flushing and cooling towels if needed. This is not right either. That says surface irrigation. You're not actually allowed to surface irrigate. It has to be subsurface irrigation for health reasons. So up to 90,000 litres per day, that's what the system is capable of recycling, and up to 30 million litres for the year. And it also has stormwater, rainwater integration, which is often needed in San Francisco because it's a very tight site and you have to deal with your water on the site. You can integrate the stormwater into the system and meet the city requirements. So, it's not cheap. First cost for this was $250 and US, and plus another $250 for installation and concrete tanks. And this is at the end of DD right now. So the prices are, they're getting firmed up reasonably, but and then what you do need to remember is this $250,000, that is going to be paid by the city because of that grant that I spoke about earlier. And they will easily use 1 million gallons per year for 10 years. And then obviously a service contract, really important maintenance on one of these systems. You do need to maintain it, obviously. I think you have to test it every month for the first 12 months, and then after that it has to be tested every 3 months, and that's the health department's requirements as well as the city of San Francisco. So this is the size of the Aquacell G20 system. It's not small, as you can see, and just to give you an idea, this is actually on another project, but this is about a 4.5 meter slab to slab height, and the reason that that's so high is because these filters in here need to come out and be taken out vertically and cleaned. So that actually can provide a lot of issues on projects. We had other projects that were looking at these systems, and when we told them, or when the vendor mentioned that, they were like, no way, we can't have a slab to slab height that much. So we came up with a solution basically of, we had a hatch in the slab above, and then car parking above it, and when maintenance had to be done, you would just not use that car park, you'd pull the hatch out, and then you could pull the filters out. So there are ways to work around this. And there are other vendors that have smaller systems, but they're not so. This is a biomembrane reactor, so it's actually based off naturally occurring bacteria, and there's not many chemicals that are used. So I just wanted to touch on the integrated greywater and rainwater part of the project, and stormwater that's not shown on this here. Rainwater comes down through a 350 micron filter into the storage tank, through the rainwater treatment skid. Rainwater doesn't need to be cleaned as much as greywater, so it's actually a different treatment, and then into the storage tank here. Greywater collection tank, you can see here, it's coming from the showers and basins I mentioned before, and then through the G20 system and into the collection tank. The tank is going to be about 80 to 90,000 litres, so it's a big tank in the basement of the building. So this is basically what water recycling looks like to the average person who uses the Oceanwide project. I wanted to sort of touch on this because it's a nice image, and this is what Foster and Partners, the designers of the building, are calling the urban room. And basically the building fabric doesn't start until the 5th level of the project, of the building. So this provides a nice open space beneath the building, and also a really good pedestrian link through the city as well. So this was just one of the projects that we worked on when I left. We had about 7 other projects that were maybe not quite as big as this, but they were definitely seriously looking at greywater recycling. And I just want to quickly touch on a couple of the projects that we actually completed while I was there as well. This is the Public Utilities Commission building. This is the institution that actually allows you to do these systems, so they kind of led the way about 5 years ago. This is a blackwater system. It's a living system, which means they use plants to do there's initial screening, and then it goes through a raised bed planter system, through aggregate, and then it goes through a more mechanically based filtration system. 80% potable water savings, and also stormwater, rainwater involved as well. And they take tours on this, and this is one of the reasons why it's actually taken off, because the PUC showed some leadership and showed it could be done, showed there was no smells and it wasn't dangerous and that sort of thing, so and they made it possible. And this is a nice image here of showing how water is taken from the snowpack through down to the city, and just how energy intensive it is, and so we're just trying to explain why we should try and reuse this water and save basically half the water that we would have used. And this is 270 Brandon. This is just an office building in downtown San Francisco. They didn't do greywater, they did stormwater, rainwater, and condensate. The condensate they told me was going to supply about 1,000 gallons each day, which I found very hard to believe, but it got signed off, and that's what we had to live with. And this is another vendor, Rehearsal. There was only about 2 vendors that we used. There's not many vendors who are actually capable of pulling off one of these systems, and they all have their different viewpoints on how it should be designed and how it should be filtered. So this is my last slide. I just want to touch on the New Zealand context and what it means for New Zealand. Obviously, we have areas in the country that are in drought as well, and they're probably going to get worse. We have supply issues with water as well. And whilst greywater recycling is not really something that's done here now, I feel like it will start to happen in the next sort of 5 or 10 years. And if you can, as utility costs increase and connection fees increase, these types of systems may become more attractive. So, and I'd definitely like to hear from you guys if you've been involved in any projects, in any greywater projects, and to discuss those. So, thank you very much. Questions?
What's the sort of mix between your biological systems and mechanical systems, with customers going which way?
It's about, well, there was basically, you have Aquacell, which is a biomembrane, so it's more, less chemical and less mechanic, and then you had Rehearsal, who was a very sort of mechanical way of filtrating, and they both argued that their system was the best. Rehearsal would say that Aquacell system could be destroyed if a whole lot of bleach went down the system, and then Aquacell would argue that, well, ours doesn't use any chemicals and that sort of thing. Well, not many chemicals, just chlorine at the end of it. So it was about half and half. What we did find is that Aquacell systems were very large, and so they were starting to be, obviously there's a space requirements, so the builders and the owners are not that happy about that. And the Rehearsal system was a lot smaller. And so what we found in the last few months we were there, Aquacell actually started designing a system of their own that was a lot more like Rehearsal's mechanical system, because just the footprint of the system was a lot smaller. And that could possibly change on this project. So when I left and up until now, it is the big biomembrane reactor, but it may change through, it may well change in the next sort of few months, and they might decide to go for a smaller, more mechanical based filtration system.
Approximately $500,000 US capital cost include the reticulation system as well, or was it just the plant?
No, that's reticulation as well. Yeah. And you got to remember that some of that reticulation is already included because it was in that zone.
Mandated.
Yeah, mandated. So, yeah. I don't think it's expensive enough. It is. I should have touched on it. It was on one of my bullet points. I think that the utility costs are predicted to rise by 10% per annum, at least 10%, and some say 30%. I think that's a bit much, but it's still pretty cheap, yeah. But there's also the stormwater, the outgoing that they have to pay for as well, which is another sort of cost saving that can be achieved.
What about the space efficiencies with a system like that? Like, presumably all the extra piping and everything, like what are they foregoing in a system like that as opposed to regular water?
Well, I mean, in terms of the risers and stacks, it's not a huge amount because it's just another greywater supply that's going up to flush the toilets, and then another one going down to take the shower's waste, not going to stormwater, or sorry, to the sewage and going down. So it's two pipes basically up the risers. So there's a little bit of a space impact, and then also the system itself takes up, I don't know, 5 to 10 car parks, which can make an impact as well. San Francisco has very tight controls on car parking in buildings anyway. You're not even allowed many, so they can usually fit in enough car parks that they're allowed to fit in as a result.
Has there been any sort of retrofits, or that just doesn't stack up?
No, not that we found. No. Anybody else? Or one back there?
Does San Francisco have a volumetric charging regime for stormwater?
Yes. Okay, well, thank you, everybody.